Hey there, welcome to NGSS Chemistry. We are going to be going over, what are we going to go over today? We're going to go over empirical formula. That's it, yeah. Alright. Percent composition, chemical composition. Okay, so our target is going to be calculating the percent by mass of a compound. Sometimes you'll see it called mass percent or percent composition. So it's all the same thing. So, when we look at the formula, we're looking at the whole number ratio of atoms in a compound. But, each element has a different mass. They get heavier and heavier as you go down the periodic table. And a lot of times we can't just count the atoms one at a time. Remember, we have to go through the mole. And even then, really, we need to measure something on a scale in the lab, like massing it. And so what really is helpful for us is to figure out the percent by mass instead of the whole number ratio. And this is what scientists did at the beginning. And by figuring out their percent by masses, they were able to backtrack it into these things called empirical formulas that will be our next lesson. But first, let's look at the percent by mass. And I got to tell you that this is a very easy concept. It's very similar to any percent. You take whatever the part is, divided by the whole amount, and then times it by 100. For instance, let's say there's a test with 100 points. You would take the part that you got correct, divided by the whole amount, 100, and times it by 100, you get your percent on the test. Let's say it's not a 100-point test. Let's say it's a 15-point quiz. And you take the amount that you got right, divided by 15, times it by 100, and you figure out what percent you got on that test. So mass percent's the same way. We're going to take a compound, and then some of that mass will be attributed to certain elements. Take the mass that's attributed to a certain element divided by the whole mass of the compound times 100, and you got the mass percent. That's it in a nutshell. Let's take a look at it the long way around. First off, let's rehash the definition of what a compound is. Okay? It's two or more elements chemically combined in a whole number ratio. That's what a compound is. And you need a chemical reaction to break them apart. Or, here's where the original definition comes into play, what I was just alluding to. Two or more elements fixed by proportions by mass. They're in fixed proportions by mass. It just so happens that those fixed proportions by mass leads to this whole number ratio. This is the law of definite proportions, and the law that gives us the definition for a compound. It's very easy to figure out in the lab. Just take a look at calculating percent by mass. Basically, find the mass of each element in the compound. Then divide the mass of each element in the compound by the total mass of the compound, and then times it by 100 to make it a percent. That's it, in a nutshell. We can actually calculate percent by mass two ways. Now that we have the periodic table and the masses on there, we could use that. Or we could just go into the lab and make some measurements. I want you to keep in mind that whenever you change anything into a percentage, all of the percents should add up to 100. Give yourself a little wiggle room for sig figs. It might be 100.01 or 99.99, and that's close enough to 100. But if it's 105, you know you did something wrong. So your percentages should add up very close to 100. So we can calculate it using lab data, which is the original way that led to the periodic table, or we can calculate it using the molar mass from the periodic table. Now that we have it, we can use it. So let's take a look at an example of both of those. Using data from a lab, let's say we do an experiment. And in the experiment, you know that two elements make up this compound. You recover a total of 5.01 grams, okay, of the compound. And when you do your experiment, you estimate that 2.36 grams of it was element A, and the rest of it is element B. Calculate the percent of each one of those elements in the compound. Well, of course, it's theoretical, right? Two different elements, A and B, make up a total. So what percent by mass is each? Okay? Very simply, okay, you are going to start with your total. Here it is, 5.01 grams. For A, you're going to take the part that is A, 2.36, divide it by the total amount, 5.01, times it by 100 to make it a percent. And look, 47.1% of it is A. Okay, for the second part of it, B, okay, how do we figure that out? Well, there's very simple. If 2.36 of it was A, and you have a total of 5.01, you can do a little subtraction problem, right? And you realize that, 2.65 must be B. So take that number, 2.65, divided by the total amount of the compound, times 100, and you get 52.9%. Notice that these two percentages must add up to 100. If they don't add up to 100, you know you did something wrong. So the percent by mass of one of these is 47.1. The percent by mass of the other one is 52.9. So that's very simple. And this is what most scientists did early on when they were trying to figure out percent by mass. What about the molar mass? Can we do this using the molar mass? Absolutely. Remember, to calculate the molar mass, all we're doing is we're taking the mass of each of the elements in a compound and adding them all together, we get to the total mass. Okay, so theoretically, we could pretend that we had 1 mole exactly of this compound. And if we had 1 mole exactly of this compound, well then take a look. We have the grams of each of them in this 1 mole exactly. You could definitely calculate the percent by mass. This is a theoretical calculation though, okay? The molar mass is the theoretical total mass of the compound. Let's take a look at a calculation using this idea. Find the percent by mass of each of the following elements in NaCl, which is table salt, okay? Wow, we need to have the mass of each of those elements, and then we need to add them together. We get to the total mass, and then we can do it, okay? Here is the solution. I'm looking on my periodic table. Sodium has a mass of 22.99. Chlorine has 35.45 for its molar mass. If I add those two numbers together, I get a total of 58.54. All I did was add them. That's the total. So I take my mass of sodium and divide it by the 58.44 times 100. Do the same thing with chlorine, and I find that there is 39.34% sodium and 60.66% chlorine in sodium chloride. Your turn. Try it. Find the percent by mass of each of the following elements in carbon dioxide. What is the percent by mass of carbon? What is the percent by mass of oxygen? Okay. If you calculate it all up, let's see, here's the solution. I wasn't sure if I had that solution slide on there. Carbon dioxide. Carbon weighs 12.01 grams. Oxygen weighs 16, but remember there's two of them, so there's a total mass of 32 grams of oxygen in carbon dioxide. Okay, add 32 and 12, and I get a total mass of 44.01 for carbon dioxide. Okay? Check your answer. In summary, the percent by mass is the amount of each element in a compound in regards to their mass. Percent by mass can be calculated from either molar mass or lab data. I'll see you back in the regular classroom if you've got any questions.